joined, the group of lines of force, these are like tube-like structure. It is like a tube structure, nothing but tube of force. So this tube of force, suppose Q charge providing number of tube of force. Q charge providing number of force Q upon epsilon naught K. K is a dielectric constant. This is medium. That means tube of force depends upon magnitude of charge and permittivity. Tube of force depends upon magnitude and permittivity. This is the tube of force. Again, tube of induction. Tube of induction. What is tube of induction? Tube of force independent on medium. Suppose medium is not considered. Q charge. Suppose this is the surface. There are so one charge is there. So this place one charge is there. This charge emits the lines of force. So this lines of force, this line any one position. That means this is tube of force released here. But how much tube of force released? That much tube of force collected here. That means tube of force collected here it is. Tube of force collected here. That means this is considered as tube of induction. Tube of induction means Q charge or Q1 charge emit the tube of induction here plus. Here same equal charge induced here. That means equal tube of force reached here. That means here we using any medium, but independent on medium. Here Q charge, Q1 charge, equal opposite charge induced here. That means tube of force independent on medium. Tube of force independent on medium. Independent on medium is called tube of induction. Is called tube of induction. Tube of induction. That means Q charge provides the number of tube of induction is Q. Again, normal electric induction. What is normal electric induction? So normal electric induction. Normal electric induction. That is nothing but NEI. NEI, number of tube of induction. So number of tube of induction, this is Q charge. It provides a tube of induction. This is tubes of force. So this is tube of force, but this tube of force independent on medium, that is called tube of induction. This is tube of induction. All direction it produces tube of induction. That means the imaginary path is considered. This is tube of induction. So tube of induction, like this is tube of induction. The tube of induction, this is independent on. Okay, tube of force independent on medium, that is called tube of induction. This induction passing through given area. Tube of induction, Q charge per unit area. Tube of induction per area, that is called NEI. Normal electric induction. NEI, normal electric induction. NEI. So normal electric induction, write as Q upon area. Area nothing but 4 pi r square. This is sphere area 4 pi r square. And NEI, normal electric induction, this is nothing but here to multiplied 1 epsilon naught k to divide 1 epsilon naught k, the equation 1 upon 4 pi epsilon naught k into Q upon R square into epsilon naught k into epsilon naught k. That is NEI, normal electric induction. This is 1 by 4 pi epsilon naught k Q upon R square. That is E intensity into epsilon naught k. naught K. This is MEI into epsilon naught K. E into epsilon naught K, that is normal E into epsilon naught K. Total normal electric induction, you know the TNEI, that is equals to total charge enclosed. So total normal electric induction area, this is called total normal
Sir,
electric
video
induction,
pausing.
that is equals to total charge sigma q. Okay, total charge. So this ఇప్పుడు కరెక్ట్ గా ఉందమ్మా?
Video pausing. I
స్టార్ట్
వీడియో ఉంది.
స్టార్ట్ అయిందా?
ట్రక్
సార్
అవుతుంది
వీడియో
సార్.
ఆగిపోతుంది, స్టక్ అయిపోతుందండి.
స్ట్రక్ అవుతుందమ్మా.
ఆ,
అంటే రికార్డ్ చేస్తున్నారు కదా.
ఇప్పుడు వినపడుతుంది సార్.
ఇజ్ ఇట్ క్లియర్? ఓకే నాన్న.
అన్నా
ఇంకా అలాగే ఉంది సార్.
ఓకే
అన్నా ఇది చూడు అన్నా.
ఎవరా నువ్వు అన్న ఎట్రా?
మా ఆవిడండి.
మా సైలెంట్ ఉంటారా బాబు? మ్యూట్ చేయి, మ్యూట్ చేయి, మ్యూట్ చేయి.
సరే సార్, సరే.
మ్యూట్ చేసేయాలి. ఓకే. So this is normal electric induction into area, that is equals to charge. Normal electric induction, already you know that E into epsilon naught K into area, that is equals to total charge. E into epsilon naught K into area. Area right as integration of ds. ds is small area. Integration of ds, that is equals to total area. So E into integration of ds, closed area, it is closed. Integration of ds equals to q upon epsilon naught K. This intensity into area, this is called flux. So flux defined as AE cos theta. AE cos theta nothing but, flux is nothing but A bar dot E bar, dot product it is. So dot product, this is called flux. Flux equals to Q upon epsilon naught K. This is flux, it is. Flux equals to Q upon epsilon naught K. That means the charge is present must be. Flux is present here. Flux equals to Q upon epsilon naught. This is electric flux. Electric flux, the units of flux, this is coulomb upon, this is epsilon naught, permittivity. Permittivity units. Unit of permittivity, that is using the force equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. Using this value, epsilon naught equals to, so this is Q square upon 4 pi F into R square. It is nothing but Coulomb square into Newton meter square. This is epsilon naught. Using this Coulomb square upon Newton meter square. So 1 coulomb is cancelled. Then flux is Newton per coulomb into meter square. This is the unit of flux. Flux unit is Newton meter square upon coulomb. Flux unit is Newton meter square upon coulomb. Just you observe, this is area meter square. Intensity Newton per coulomb. Intensity Newton per coulomb into meter square. So this is flux, electric flux. That means electric flux we calculate phi equals to Q upon epsilon naught K. But using Gauss theorem, and Gauss theorem applications are used to we calculate this. TNEI, total normal electric induction, that is equals to total charge enclosed in a closed surface. Okay, so using this Gauss theorem, another one application is So Gauss theorem and applications. Using this Gauss theorem applications, what is the condition? So this is to calculate intensity. Intensity given by, suppose this is one non-uniform surface. Non-uniform surface, that condition. So this is, this place we want intensity. So this place intensity. So this place, what is the intensity here? This place we want intensity. This is, here intensity is E bar. Here surface area, that is ds, small, total surface area, integration of ds, total. This is a total surface area. This is total surface area. So that is ds. This is equals to d, integration of ds. Small surface area, ds indicates aerial vector, small surface aerial vector. Aerial vector. E bar, it is nothing but intensity. Intensity on surface. On surface it is. But the charge on this surface, this is the total charge. So this place, the charge on this surface it is. Charge on this surface, this charge providing intensity, the total charge providing intensity, that is nothing but that is E. Total charge providing intensity, that is E. Total charge providing intensity. Just outside E, inner side, inside the intensity becomes zero. Inside the body, intensity becomes intensity E equals to 0. Outside intensity is there. Inside the body intensity, inside the intensity becomes 0. Inside the body, the intensity is 0. So that means just outside the intensity is present, just inside the intensity becomes 0. That means what is the condition here? That means just the observation, the given one condition. This ds surface, the charge on ds surface, that is dq. Charge on ds surface, that is dq. So charge on ds surface, that is nothing but dq. This intensity given by dq charge. dq charge is E1. Intensity given by remaining, okay, charge on remaining surface. Remaining surface, that is E2. Intensity given by ds, only the charge on ds surface, that is E1. Intensity given by remaining charge, this is remaining charge, this total charge providing intensity, that is E2. Outside, just outside, the intensity E equals to E1 plus E2. Means just outside, ds charge providing intensity E1, remaining charge providing intensity E2, just outside the intensity becomes E1 plus E2. Again, just inside, the intensity becomes 0, means this value becomes E1, E equals to E1 minus E2. So it is 0. Just inside the intensity, inside at everywhere the intensity becomes 0. Intensity at everywhere, that value becomes 0. Just inside, E equals to E1 minus E2. Outside the intensity becomes, that is E1 plus E2. but inside the intensity becomes E1 minus E2. So inside intensity becomes 0. So this is the inside intensity. Just having any doubts, please ask me. ఏమైనా డౌట్ ఉన్నట్టయితే చెప్పండమ్మా. Having any doubt? This is one charged body. So this charged body providing intensity outside, that is E. Just inside the intensity becomes 0 because no charge inside, so must be intensity inside becomes 0. So but here we considered some charge on ds surface and remaining charge other this surface. This surface, the charge providing intensity becomes E1. This surface, ds surface, the charge providing intensity E1. And remaining surface, the charge providing intensity becomes E2. So that means this charge providing intensity E1, remaining charge providing intensity E2. Outside intensity is there, that intensity equals to E1 plus E2. Just inside the intensity becomes 0. That means E1 minus E2. Subtraction, that case only possible, resultant becomes 0. Having any doubt? చెప్పండి, ఏమైనా డౌట్ ఉంటే అడగండి. Ask me having any doubt. Okay, you know that what is the intensity on outside? Intensity on surface. Intensity on surface of charged body. This is write as TNEI, that is equals to total charge. Total charge is considered, that is Q. TNEI, this is write as E into epsilon naught K into integration of ds. That is equals to total charge. So E equals to, so intensity E equals to, this is write as E equals to Q upon integration of ds into epsilon naught K. Charge upon area, that is write as sigma, charge density upon epsilon naught K on surface. So integration of here, integration of ds means total area. So Q upon area, that is sigma. Sigma is surface charge density. Surface charge density. This is sigma. Epsilon naught K permittivity. So on surface intensity, sigma upon epsilon naught K. Just you observe on surface intensity, sigma upon epsilon naught K. So that is equals to E1 plus E2. But here, E1 minus E2 equals to 0. That means E1 equals to E2. So E1 minus E2 equals to 0 means E1 equals to E2. E1 equals to E2 means, suppose E1 intensity given by charge on this surface. E1, that is intensity given by charge. Okay. The ds surface given by charge. So ds surface, the charge is dq. The dq charge providing intensity, that is E1. So E1 equals to E2. So E1 equals to E2. So it is write as E1 plus E2, that is 2E1 or 2E2. This is equals to sigma upon epsilon naught K. Suppose we want E1 value. E1 equals to sigma upon 2 epsilon naught K. Or E2 is nothing but sigma upon 2. E2 is nothing but sigma upon 2 epsilon naught K. So E1 or E2 value. E1 means the charge on this surface, the charge providing intensity, sigma upon 2 epsilon naught K. Remaining charge providing intensity, that is also same, sigma upon 2 epsilon naught K. That means nearer position, this surface, the charge providing intensity E1 and remaining charge providing intensity E2. So outside E1 minus E2. But inner side, so this charge providing intensity E1, this remaining charge providing intensity E2. So here resultant intensity becomes 0. intensity 0 means E1 minus E2. Inside, resultant intensity E1 minus E2. Outside, intensity E1 plus E2. So E1 value sigma upon 2 epsilon naught K. E1, only this surface, the charge providing intensity E1 equals to sigma upon 2 epsilon naught K. Our remaining charge providing intensity same sigma upon 2 epsilon naught K. ఈ పాయింట్ అనేది మీకు అర్థమైనట్టయితే నెక్స్ట్ కాన్సెప్ట్ ఈజ్ వెరీ ఈజీ. హ్యావింగ్ ఎనీ డౌట్ ప్లీజ్ ఆస్క్ మీ. చెప్పండి అమ్మా, ఏమైనా డౌట్స్ ఉన్నట్టయితే చెప్పండి. దిస్ ఈజ్ ద మెయిన్ కాన్సెప్ట్ ఫర్ మెకానికల్ స్ట్రెస్. చెప్పమ్మా, ఆస్క్ మీ. Mechanical stress, this is the concept, basic concept of mechanical stress. Satish చెప్పండి. Having any doubt please ask me. చెప్పండి అమ్మా, ఏమైనా డౌట్ ఉన్నట్టయితే. Very simple. We consider this is one total charge is accumulate on the surface. Total charge accumulate on the surface. We considered one small area, that is ds. This ds surface, the intensity is E. So we consider ds surface, the charge is dq. ds surface, the charge becomes dq. This dq charge providing intensity E1. Remaining charge providing intensity E2. Here intensity becomes on surface intensity sigma upon epsilon naught K. So outside the intensity sigma upon epsilon naught K, that is equals to E1 plus E2. Just inner side intensity becomes 0. That means this charge providing intensity, remaining charge providing intensity, both equal and opposite. So E1 minus E2, that value becomes 0. Inside intensity becomes 0 means E1 and E2 are opposite direction. So that condition intensity 0. So E1 equals to E2. Then E1 value is E2. Then this is write as 2E1 or 2E2. That value equals to sigma upon epsilon naught K. Where E1 equals to sigma upon 2 epsilon naught K. E1 means this charge only providing intensity. This charge on only ds surface, charge on only ds surface, this charge providing intensity sigma upon 2 epsilon naught K. Okay, ఏమన్నా డౌట్ ఏమైనా ఉంటే అడగండి అమ్మా. Very interesting, important topic it is. Having any doubt please ask me. ఏమైనా డౌట్ ఉంటే అడగండి అమ్మా. Having any doubt?
సార్
చెప్పమ్మా, చెప్పండి. Next one. Next one it is right. So E1, this charge providing intensity E1. So here, okay, this charge is repelled of this charge. This is plus, this is also plus, and this charge also, this charge, every charge repelled. Every charge repelled means the repulsive force is acting like this. This is the repulsive force. Every charge repelled this. That means the repulsive force we want. Here the charge is suppose dq or q charge, small q charge. Total charge capital Q. So this place we considered small charge, that is small q. So this charge also repelled. This charge also repelled. That means here the force we want. Force on the small charge dq or force on this charge. Force on charge, okay, force on charge, small charge, or force on the small charge, force on small charge. This is right as force on small charge, force equals to intensity provided by this total charges, intensity provided by this total charges. This total charges providing intensity E2 into charge. Here charge is, that is nothing but ds surface, the charge is dq. Suppose we using dq charge. Intensity into charge, that is nothing but force. F equals to E2 into dq. Here every charge is repelled. So every charge is repelled, then E2 into dq. It is write as E2 write as sigma upon 2 epsilon naught k into charge dq into charge dq. That means this surface, the force on this surface, same as this surface also force is acting. This charge repelled, this charge repelled, this charge repelled. So this charge also repelled this charge. So this place also force is there. Same as this place also force is there. This place also force is there. Every position the force is acting. Then the size of this body is increases. This is the condition. Why the charge given after the body size increases means the body expand. So body expand. Why expand? These charges applying force on this place. Same as these remaining charges applying force on this place. So remaining charges applying force on this place. So every position the force is acting, the size of the body is increases. So the question, the charge is given to a soap bubble charge given to a soap bubble, what happened? When charge given to a soap bubble, the size of the soap bubble is increases. This is the condition. When the charge is given to a soap bubble, the soap bubble size increases, either negative charge or positive charge. Any charge is providing, then the soap bubble size is increases. So this is the region the soap bubble size is increases. That means every position the force is acting, that force is repulsive force, then this surface is slightly increases. The size slightly increases. This size also increases. This size, every part size increases. That means this is expand. The body is expand. That means this size increases. That means due to this force equals to sigma upon 2 epsilon naught k into dq. Then total force on the body, total force means sigma F. That condition using integration, total charge. So total charge we using sigma upon 2 epsilon naught k. This is total force sigma F. Okay, so small charge, force on small charge F. Suppose total force we want, sigma F is right as, this is sigma upon 2 epsilon naught k integration of dq. Integration of dq. Only small charge, force on small charge, F equals to E2 into dq. Total force on the body, total force. This is nothing but total force on body. That is nothing but sigma upon 2 epsilon naught k integration of dx. So this is right as sigma upon 2 epsilon naught k into total charge q. So this is, we consider total force on the body. Force per area, that is called stress. We consider the concept of mechanical stress. Mechanical stress is right as force per area. This is the concept. Mechanical stress. Mechanical stress on the body, or mechanical stress right as stress nothing but force upon area. Total force of the body upon total area. Total force upon total area. This is called mechanical stress. Total force sigma upon 2 epsilon naught k into charge upon area. Charge per area, that is sigma, charge density. Charge per area, this is nothing but sigma, charge density. So it is right as sigma. Sigma into sigma square. Sigma square upon 2 epsilon naught k. This is mechanical stress. Mechanical stress it is. Mechanical stress, that is right as sigma square upon 2 epsilon naught k. Mechanical stress is right as sigma upon, say, sigma square upon 2 epsilon naught k. So sigma indicate charge density, charge per area. This is called charge density, charge per area. This is called charge density. Charge per area, charge density. This is sigma equals to Q upon A. Sigma square upon 2 epsilon naught k. This is mechanical stress. Or this is, stress is nothing but mechanical. This is energy density. Stress is nothing but energy density. Stress is nothing but energy density. So it is called energy density. Stress or energy density both are same terms. Energy density. One question in last JEE exam on this concept. What is the mechanical stress? Why the body size is increases? The body size increases due to this is the expansion. The body size is increases due to this is expansion. It is. So this is the body size is increases due to this is expansion. So the condition is suppose any body is so charge is provided to any body. That condition the body is size increases. This is called mechanical due to mechanical stress or energy density. The size of the body is increases due to the remaining charges applying force on this. Remaining charges applying force on this. Remaining charges applying force on this body. Okay. So this is the concept. The body is expand or its size increases. Its size increases. This is the main reason. Okay. Tell me having any doubt. ఏమైనా డౌట్ ఉంటే అడగండి అమ్మా. Tell me having any doubt. Having any doubt. Having any doubt. చెప్పండి భరత్ చంద్ర చెప్పండి. ఆస్క్ మీ హ్యావింగ్ ఎనీ డౌట్. చెప్పండి భరత్ చంద్ర.
మెకానికల్ స్ట్రెస్ గురించి చెప్పరా ఒకసారి.
మెకానికల్ స్ట్రెస్.
స్ట్రెస్.
ఓకే. Mechanical stress. Stress means force per area. So only one surface we calculate the force. Force nothing but intensity into charge. Force nothing but intensity into charge. Intensity given by, so this total charge providing intensity here E2, and this place the charge is that is dq. E2 into dq. E2 write as sigma upon 2 epsilon naught k into dq. It is sigma upon 2 epsilon naught k into dq. So it is write as, so sigma, okay, sigma upon 2 epsilon naught k, that is E2 into charge. This place charge is that is dq. So the dq into intensity, that is nothing but force on this surface. Force on this surface, that is sigma upon 2 epsilon naught k into dq. So everywhere the force is acting, here also force is acting. These remaining charges applying some force. This place also force is acting. The remaining charges applying force on here. Then the body size increases. So everywhere the force is acting. Then total force acting on the body. The total force on the body means sigma, summation of this one, this one, this one. Summation, that is sigma f equals to sigma upon 2 epsilon naught k integration of dq. Total charge. Total charge nothing but that is q. Sigma upon 2 epsilon naught k into q. You know that mechanical stress defined as total force upon total area. Total area, that is nothing but integration of ds, that is nothing but a. So total sigma upon 2 epsilon naught k into q upon area. So mechanical stress is right as sigma square upon 2 epsilon naught k. So it is right as sigma square upon 2 epsilon naught k. This is q upon a, nothing but sigma. Charge density, surface charge density, charge per area, charge density sigma square upon 2 epsilon naught k. Mechanical stress is nothing but energy density. Stress means force per area. So stress nothing but force per area. So into displacement, force into displacement. that is work. Work upon, area into displacement volume. Work upon volume, it is nothing but energy per volume. So energy upon volume, this is nothing but energy density. It is nothing but energy density. Mechanical stress is nothing but, that is energy density. Mechanical stress is nothing but energy density. Mechanical stress write as force per area. Displacement to multiply the displacement to multiply on both sides. So the force into displacement work, area into displacement volume. So work is nothing but energy per volume, that is called energy density. So energy density or mechanical stress, sigma square upon 2 epsilon naught K. Energy density or mechanical stress, this is nothing but, okay, sigma square upon 2 epsilon naught K. Okay. చెప్పండి, having any doubt? ఏమైనా డౌట్స్ ఉన్నాయా?
సరే, మెకానికల్ స్ట్రెస్ అని కొన్ని మీనింగ్ చెప్తారా? అంటే మెకానికల్ స్ట్రెస్
అంటే అంటే ఉదయం నుండి నువ్వు కూర్చొని చదువుకుంటున్నావు అమ్మా. అంటే సాయంత్రం అయ్యేటప్పటికి నీ మీద చాలా ప్రెషర్ వస్తుందా, స్ట్రెస్ వస్తుందా? అంటే బాగా స్ట్రెయిన్ అవుతావా అవ్వవా? అంటే దట్ స్ట్రెయిన్, దట్ ఈజ్ మెకానికల్ స్ట్రెస్. స్ట్రెస్ అంటే ఈ అన్నీ కలిపి దీన్ని బయట తోసేస్తాను, నెట్టేస్తాను. అంటే దీస్ చార్జెస్ ఆర్ అప్లైయింగ్ సమ్ ఫోర్స్ ఆన్ దిస్ సర్ఫేస్, సేమ్ యాజ్. అంటే ఇప్పుడు చూడండి అమ్మా, మనకి బోల్డ్ అనే పొలిటికల్ పార్టీస్ ఉంటాయి. ఇదొక పార్టీ, ఇదొక పార్టీ, ఇదొక పార్టీ. ఇది టీడీపీ, ఇది వైసీపీ, ఇది బీజేపీ, ఇది కాంగ్రెస్. వీళ్ళు చూడండి, వీళ్ళందరూ కలిసి ఈ టీడీపీని బయటకు నెట్టేస్తారు. తర్వాత అంటే ఈ వైసీపీ, కాంగ్రెస్, బీజేపీ వీళ్ళందరూ కలిసి టీడీపీని బయటకు నెట్టారు. సో తర్వాత ఇది వైసీపీని మనం చూడండి, టీడీపీ అండ్ కాంగ్రెస్ అండ్ బీజేపీ అండ్ సిపిఐ, సిపిఎం, ఇవన్నీ కలిపి దీన్ని పైకి నెట్టడానికి ట్రై చేస్తారు. దీన్ని పైకి నెట్టారు అంటే దీన్ని అపోజ్ చేస్తుంటారు. తర్వాత ఇక్కడ ఒక బీజేపీ ఉంది. ఇవన్నీ కలిపి వైసీపీ అంటే ఒకరినొకరు విమర్శించుకోవటమే ఇక్కడ కండిషన్. అంటే ఇవన్నీ కలిపి ఈ ఛార్జ్ని రిపల్ చేస్తారు. తర్వాత ఇవన్నీ ఈ ఛార్జెస్ అన్ని కలిపి ఇక్కడ ఉండే ఛార్జ్ని రిపల్ చేస్తాయి. అంటే ప్రతి ఛార్జ్ మీద కూడా ఎంతో కొంత ప్రెషర్ అనేది యాక్ట్ అవుతుంది. అలా ప్రెషర్, దట్ ప్రెషర్ ఈజ్ నథింగ్ బట్ స్ట్రెస్. ప్రెషర్ ఇన్ స్ట్రెస్ అంటాం. ప్రెషర్ ఈజ్ నథింగ్ బట్ స్ట్రెస్. ద ప్రెషర్ డెఫినేషన్ ఈజ్ ఫోర్స్ పర్ ఏరియా. The stress definition is force per area. Force per area, this is called stress or this is called pressure. Pressure nothing but force per area. అంటే ఈ బాడీ ఈ చార్జ్ మీద ఎంతైతే ప్రెషర్ యాక్ట్ అవుతుందో దీని మీద అంతే యాక్ట్ అవుతుంది, దీని మీద అలా అన్నింటి మీద ఫోర్సెస్ అనేవి యాక్ట్ అవుతున్నాయి. ఫోర్స్ పర్ ఏరియా, దట్ ఈస్ కాల్డ్ ప్రెషర్ ఆర్ స్ట్రెస్. టోటల్ బాడీ పైన మనకు ఎంతైతే స్ట్రెస్ యాక్ట్ అవుతుంది అనేది మనం చూసుకున్నట్టయితే దిస్ ఈజ్ ద మెకానికల్ స్ట్రెస్. కాబట్టి సోప్ బబుల్ కి మెకానికల్ స్ట్రెస్ అనేది ఉండటం వల్ల సోప్ బబుల్ ఛార్జ్ ఇచ్చిన తర్వాత సోప్ బబుల్ యొక్క రేడియస్ అనేది పెరుగుతుంది. వై ద రేడియస్ ఆఫ్ ద సోప్ బబుల్ ఈజ్ ఇంక్రీజెస్. ఎందుకు ఇంక్రీజ్ అంటే ఈ ప్లస్ ఛార్జ్ని ఈ ప్లస్ ఛార్జ్ రిపల్ చేస్తుంది, ఈ ప్లస్ ఛార్జ్ రిపల్ చేస్తుంది. ఆటోమేటిక్గా దీని యొక్క సైజ్ పెరుగుతుంది. ఈ ప్లస్ ఛార్జ్ ఇది రిపల్ చేస్తుంది, ఇది రిపల్ చేస్తుంది. అలా ప్రతిదీ కూడా రిపల్షన్ అనేది ప్రతి దాని మీద యాక్ట్ అవటం వల్ల దాని యొక్క సైజ్ అనేది పెరుగుతుంది. ఇది ఇక్కడ ఫోర్స్ పర్ ఏరియా, దట్ ఈస్ కాల్డ్ స్ట్రెస్. ఇట్ ఈస్ ఫోర్స్ పర్ ఏరియా, దట్ ఈస్ కాల్డ్ స్ట్రెస్. ఇట్ ఈస్ ఓకే. ఇంకా ఏమైనా డౌట్స్ ఉంటే చెప్పండి. Please ask me having any doubt. చెప్పండి అమ్మా, ఏమైనా డౌట్స్ ఉన్నట్టయితే చెప్పండి. ఓకే, ఈజ్ ఇట్ క్లియర్? మెకానికల్ స్ట్రెస్. Stress means force per area. That force per area in electricity, sigma square upon 2 epsilon naught K. Sigma surface charge density. Okay, next one. The question is given. So the question, the electric intensity, problem is given that electric intensity on surface 320 Newton per Coulomb. On surface 320 Newton per Coulomb. Okay, electric intensity on surface 320 Newton per Coulomb. And find energy density of charged body. So this is the question, energy density. Already just the concept is completed, but the given electric intensity is given. Intensity is given 320 Newton per Coulomb. But you know that energy density or mechanical stress, energy density or mechanical stress, this formula, mechanical stress, that formula, you know that 1 upon, so that is write as mechanical stress sigma square upon 2 epsilon naught K. The formula is this, but the given intensity. Intensity is given, we want energy density. But the derived formula is energy density or mechanical stress, that is sigma square upon 2 epsilon naught K. Sigma square upon 2 epsilon naught K, this is the energy density or mechanical stress formula. You know that any non-uniform body, this is one non-uniform body. So this non-uniform body, the charge accumulate on the surface. This is the charge. Okay, charge accumulate on the surface. Charge per area. This is sigma charge density. Charge, total charge per area. This is sigma charge density. But non-uniform surface, this place, what is the electric intensity? You know, electric intensity, E equals to, so E equals to sigma upon 2 epsilon naught K. Otherwise, here total charge Q and area of this body is A. So sigma equals to Q upon A. But this is TNUEI, Gauss theorem. Using Gauss theorem, total normal electric induction, that is equals to total charge Q. TNEI is equals to total charge. TNEI is equals to total charge. You know that E into epsilon naught K into integration of ds means area. Integration of ds means total area, that is equals to Q. E into epsilon naught K into integration of ds means that is area, that is equals to Q. So E equals to Q upon A into epsilon naught K. So E equals to charge per area sigma upon epsilon naught K. This is the intensity and surface charge density between the relation. Intensity and surface charge density, that relation is sigma upon epsilon naught K. E equals to sigma upon epsilon naught K. Sigma upon epsilon naught K, that is intensity. Okay. So intensity equals to sigma upon, using here, then this is sigma position using intensity and epsilon naught K. This formula, this is write as, so this is E into epsilon naught K whole square upon 2 epsilon naught K. Then it is write as E square into epsilon naught K whole square upon 2 epsilon naught K. K cancel, 1 epsilon naught cancel. So this is of epsilon naught K into E square. This is the mechanical stress, okay, or energy density. Mechanical stress or energy density, it is write as half epsilon naught K into E square. Our problem is E is given. So stress or energy density, this value becomes of epsilon naught 8.85 power minus 12. In air, dielectric constant, that is 1. Not given dielectric constant, that is 1 into 320 whole square it is. So this is 4.425 into 10 power minus 12 into 30 to 320 into 320. 30 to 32, 102400. This is the square of this. 320 whole square. This is nothing but 102400. So this is after multiplication, this value 4.425 into 1.024 into 10 power 1, 2, 3, 4, 5, 10 power minus 7. So after multiplication, 4.425 into 1.24, it is approximately 4.5 into 10 power minus 7. So this is energy density, energy density. So energy density means energy per volume, joule per meter cube. This is the units. This is the problem of this question. Okay. E problem ki e question another like this is the problem. So here just we using that the relation is energy density, mechanical stress. This is right as sigma square upon 2 epsilon naught k. So using this relation E equals to sigma upon 2 epsilon naught k on surface. So E equals to sigma upon 2 epsilon naught k. So this is sigma square. Mechanical stress is right as sigma square upon 2 epsilon naught k. Sigma position using E into epsilon naught k whole square. That is 2 epsilon naught k. After simplification, the mechanical stress is, this is the value of mechanical stress of epsilon naught k into E square. Of epsilon naught k into E square. This is the value of the equation. So after simplification of that problem, this value becomes this. Okay. Please ask me having any doubt. చెప్పండమ్మా ఏమైనా డౌట్ ఉన్నట్టయితే.
సార్ ఎనర్జీ డెన్సిటీ ఒకసారి చెప్పండి సార్.
ఎనర్జీ డెన్సిటీ అంటే ఎనర్జీ పర్ వాల్యూమే కదమ్మా. మెకానికల్ స్ట్రెస్ నే మనం ఎనర్జీ డెన్సిటీ అంటాం. స్ట్రెస్ అంటే ఫోర్స్ పర్ ఏరియా కదమ్మా. ఫోర్స్ పర్ ఏరియా, దిస్ ఇస్ కాల్డ్ స్ట్రెస్. ఓకే, స్ట్రెస్ ఈజ్ నథింగ్ బట్ ఫోర్స్ పర్ ఏరియా. ఫోర్స్ ఇంటూ డిస్ప్లేస్మెంట్, డిస్ప్లేస్మెంట్ తో మల్టిప్లై అండ్ డివైడ్ చేసాము. ఫోర్స్ ఇంటూ డిస్ప్లేస్మెంట్ దట్ ఈస్ వర్క్. Work upon area into displacement volume. Work per volume, that is nothing but energy per volume. Energy upon volume, this is nothing but energy density. This is nothing but energy density. Mechanical stress, nothing but energy density. Mechanical stress ne energy density antam. So mechanical stress. So suppose sigma square upon 2 epsilon naught k, this is mechanical stress. దాన్ని ఇప్పుడు మనం కన్వర్ట్ చేస్తున్నాం. మనకి ఇచ్చిన డేటాలో ఇంటెన్సిటీ ఓన్లీ గివెన్. Intensity only given. Using that intensity we calculate energy density or mechanical stress. Both are similar, same terms. Energy density and mechanical stress both are same terms. Energy density and mechanical stress both are same. Energy density and mechanical stress both are same. Then this condition we using that sigma square upon 2 epsilon naught k. So this is sigma square upon 2 epsilon naught k. Sigma value, just you know that total normal electric induction equals to total charge. TNEI, normal electric induction into area, that is equals to charge. E equals to sigma upon epsilon naught k, because Q upon area, sigma upon epsilon naught k, this is intensity. So here sigma equals to intensity into epsilon naught k. Sigma equals to intensity into epsilon naught k whole square upon 2 epsilon naught k. After simplification, the mechanical stress or energy density, that is right as half epsilon naught k into E square. So E value you know 320, and energy density of epsilon naught value 8.85 into 10 power minus 12 into K, dielectric constant 1 into 320 whole square. After simplification, the energy density or mechanical stress, that is right as 4.5 into 10 power minus 7 joule per meter cube. Energy density or mechanical stress, that is unity joule per meter cube. Energy per volume, energy per volume or force per area. So it is right as joule per meter cube or Newton per meter square. joule per meter cube, work per volume, or force per area. Both same, it is energy density. Okay. Tell me, having any doubt? Emana doubt unte cheppandamma. Mechanical stress, it is write as force per area. To multiply displacement, to divide displacement, this is force into displacement work, area into displacement volume, work per volume, work nothing but energy, energy per volume, that is called energy density. This is called mechanical stress, nothing but mechanical stress, nothing but energy density. Okay, mechanical stress, nothing but energy density. Mechanical stress and energy density both are same. That formula, sigma square upon 2 epsilon naught k. So half into epsilon naught k into E square. Okay. ఏమైనా డౌట్ ఉందమ్మా? డౌట్ ఉన్నట్టయితే మరొకసారి ఎక్స్ప్లెయిన్ చేస్తాను. E ఈక్వల్స్ టు epsilon naught k equals to sigma. This value, okay, so this value put here, this equation, E into epsilon naught k equals to sigma. So then we getting energy density, one new formula. Okay. Tell me, having any doubt? Tell me, having any doubt, please ask me. Okay. Next problem is, so another one problem is given that the charge on the surface of a non-uniform body. So this is one paper surface. This is plate. Okay. Charge, Q charge on surface of a plate.
పైన కనిపించట్లేదు సార్.
Okay, Nama. Q charge on surface of a plate. Okay, Q charge on surface of plate. Find intensity on its surface. On its surface. So this is one paper, it is. Q charge on surface of a plate. Q charge on its surface of a plate, like this. Like this. Q charge on surface of plate means, just you observed, this is one plate. Plate means charge occupied on this surface as well as back side. Charge on this surface as well as back side. Charge accumulate on two surfaces. That means total charge accumulate on two surfaces, 2A. Okay, charge accumulate on two surface. That means one surface having charge Q by 2 upon area. This front side, this side, the charge is Q by 2 upon this area. And back side, the charge is Q by 2 upon area. This condition, what is we considered, what is the intensity on its surface? You know that intensity TNEI, total normal electric induction, equals to total charge enclosed in a closed surface. It is write as E into epsilon naught k into integration of ds. So that is equals to total charge enclosed. So this surface we considered, this is sigma q. This surface is considered, that is A. This surface, one side surface we considered A. This side surface A into E into epsilon naught k. This is equals to charge. One surface, the charge is equals to Q by 2. One surface, this side, this surface having charge Q by 2. Then E into epsilon naught K. We want the intensity. Intensity equals to Q upon 2 into epsilon naught K into A. So E equals to Q upon 2 epsilon naught K into A. Q upon A, that is nothing but sigma. Sigma is charge density Q by A. Then intensity becomes equals to sigma upon 2 epsilon naught K. On any paper plate or any plate, the charge is accumulate. That condition we considered intensity on the surface, sigma upon 2 epsilon naught K. Sigma upon 2 epsilon naught K, that is total Q charge. Total Q charge accumulate on its surface, on surface of plate. That condition we using total normal electric induction, that is equals to total charge. Total normal electric induction equals to total charge. Then TNEI, that is equals to sigma Q. TNEI, this is normal electric induction into area, that is sigma Q. Normal electric induction E into epsilon naught K, integration of ds, that is A. That is equals to charge with the charge Q by 2. Then E equals to Q upon 2 epsilon
సార్ మీ వాయిస్ మ్యూట్ లో ఉంది సార్.
that is nothing but Q upon epsilon naught K. Tube of induction, that is Q. Tube of induction, that is Q. Another one is normal electric induction. This is Q upon A, or it is nothing but E into epsilon naught K. And another total normal electric induction. This is right as E into, so that is equals to total charge. E into epsilon naught K integration of ds. This is equals to total charge. Again, flux. So flux nothing but, okay, it is right as Q upon epsilon naught K. Or it is right as flux equals to AE cos theta, A bar dot E bar. This is flux. And again we write as mechanical stress. So stress or energy density. Stress or energy density. Energy density or stress sigma square upon 2 epsilon naught K. And after any plate surface, so plate surface, the intensity on the surface of any body, but that is a sigma upon epsilon naught K, but on plate surface sigma upon 2 epsilon naught K. Any body surface sigma upon epsilon naught K, but plate surface the intensity sigma upon 2 epsilon naught K. This is the concepts we completed in Gauss theorem and Gauss application. This is Gauss theorem. It is total normal electric induction, that is equals to total charge. That is Gauss theorem. Again, so using Gauss application, sphere, cylinder, or any charged body. So this is formulas of tubes of force Q upon epsilon naught K. And tube of induction, the tubes of force independent on medium, that is called tube of induction. Q charge provides Q tube of induction. Another one, normal electric induction, Q upon A, tube of induction per area, that is normal electric induction. That is E into epsilon naught K. K dielectric constant, its value for air 1, water 80, metal infinite. And total normal electric induction is equals to total charge. This is Gauss theorem, or so E into epsilon naught K, normal electric induction into area. That is called total normal electric induction. So E into integration of ds, that is nothing but Q upon epsilon naught K. This is flux. Flux phi equals to A bar dot E bar. So mechanical stress or energy density sigma square upon 2 epsilon naught K. And plate surface intensity sigma upon 2 epsilon naught K. Any body, that condition sigma upon epsilon naught K. Only plate that condition sigma upon 2 epsilon naught K. Okay. Having any doubt? The Gauss theorem and its applications are completed. Having any doubt? ఏమైనా doubts ఉంటే చెప్పండి అమ్మా. Having any doubt? The one concept just okay. This is non-conducting sphere is given. Non-conducting sphere, that condition. Okay. So non-conducting sphere, okay, charged sphere, non-conducting charged sphere. Suppose this is one non-conducting, that means charge accumulate inner side also. Charge accumulate inner side also. This is called non-conducting charged sphere. Non-conducting charged sphere. Already you know that total normal electric induction. So conducting sphere, charge accumulate only on surface. Conducting sphere, charge accumulate on the surface. This radius is R. But here we considered intensity. So smaller distance, we want the intensity. This condition very simple, TNEI, that is equals to total charge Q. This rule E into epsilon naught K into integration of ds, that is equals to total charge. So like this way we complete. But here non-conducting means charge inside also. But we want, so outside the same rule, but here we want intensity. So intensity we want here. What is the intensity here? This place we calculate intensity. This place intensity not 0. Conducting sphere, that condition inside intensity 0 at everywhere, here, center at everywhere. But this condition intensity not 0. This is non-conducting sphere. Non-conducting charged sphere intensity not 0. So this case, how to simplify the intensity? Inside intensity not 0. What is the value of intensity? But this case, so normal electric induction is equals to the total normal electric induction. This Gaussian surface. This Gaussian surface is what is the charge? Of Q, capital Q charge. Total, this radius is 4/3 pi capital R cube. 4/3 pi capital R cube. This surface consists of Q charge. Surface, this radius smaller. This radius smaller, pi capital R cube. 1 unit volume. 1 unit volume consists of this charge. Again, this volume consists of how much charge? This volume consists of how much charge? 4/3 pi small r cube consists of, the charge becomes Q upon 4/3 pi r cube into 4/3 pi small r cube, and these terms are cancelled. Then
సార్ మీ వీడియో బఫర్ అవుతుంది.
surface. Gaussian charge is small. Charge becomes capital Q. Only Gaussian surface inside the charge becomes small q. Small q equals to capital Q into R cube by R cube. So this is the charge on. Okay, inside the charge becomes Q R cube by R cube. But you know that Gauss theorem, TNEI, that is equals to total charge enclosed in a closed surface. This Gauss surface inside the charge is small q. Total normal electric conduction, E into epsilon naught K into Gaussian surface area, integration of ds. That is equal to charge Q into R cube upon capital R cube. This is E into epsilon naught K, area of this. So 4 pi small r square, that is equal to Q into R cube by R cube. So R square and R cube cancel, then E is brighter. This time it changes this side. 1 upon 4 pi epsilon naught K into Q into small r by R cube. Inside, the intensity not zero. This is inside intensity here. Smaller distance, we want the intensity. Smaller distance, we want the intensity. Inside the non-conducting, just you observed, it is not a conducting, non-conducting. Conducting, the charge accumulate only surface, not inside. Non-conducting, charge accumulate inside also. Non-conducting means it is a plastic ball, rubber ball. Plastic ball, rubber ball, inside also charges accumulate. Non-conducting surface, intensity is this. At center position, at center of non-conducting sphere, it is non-conducting, not conducting. Conducting or halo, this condition inside intensity, conducting or halo inside intensity must be zero. But non-conducting inside intensity not zero. At center position, small r equals to 0. Center position, small r 0. So intensity 0. Center position only, intensity 0. Only center of this sphere, intensity 0. Suppose small r distance. So displacement, small r distance from center. The intensity becomes E equals to 1 by 4 pi epsilon naught Q upon R cube into small r. That means center position to distance increases, intensity increases, directly proportional, E proportional to R. Intensity increases, distance increases, intensity increases. On surface maximum, small r equals to capital R. Surface, that is intensity is maximum. So center to up to surface intensity increases, then surface after the formula is same. Okay, this is a non-conducting sphere. Non-conducting sphere, the formula is different. Inside intensity not zero, only center position intensity becomes 0. Inside intensity, center position only 0. Remaining everywhere the intensity is present. But conducting or halo, inside intensity must be 0. Conducting or halo, that means suppose it is a metal sphere, inside no charge, intensity 0. But this one rubber ball inside, intensity is there, the charge is present, then intensity is present. Okay, non-conducting, the special formula, this is the non-conducting sphere, the intensity is this. Okay, చెప్పండి అమ్మా, ఏమైనా డౌట్స్ ఉన్నట్టయితే చెప్పండి. Having any doubt? Non-conducting sphere, the intensity is presence. Okay, inside intensity is presence. చందన, సాయి లక్ష్మి చెప్పమ్మా, ఏమైనా డౌట్ ఉందమ్మా సాయి లక్ష్మి?
నో సార్.
ఓకే, చందన చెప్పండి అమ్మా. స్వరూప్, వంశీధర్, తోషిత, ఆదిత్య, మెరువ, ఒకసారి చెప్పండి అమ్మా, ఏమైనా డౌట్ ఉన్నట్టయితే చెప్పండి. చూడండి, ఇది ఒక స్పెషల్ కండిషన్, ఇది నాన్ కండక్టింగ్ స్పియర్ కి ఒక స్పెషల్ కండిషన్. బట్ అవుట్ సైడ్ ఇక్కడ ఇక్కడ కండక్టింగ్ లో, బట్
సార్ వీడియో
ఇన్సైడ్
ఆన్ చేయండి సార్.
కండక్టింగ్ లో జీరో అయిపోతుంది. అదే ప్రాపర్టీ 1/4πε0 అవుట్ సైడ్ ఇక్కడ మన ఇంటెన్సిటీ కావాలి. 1/4πε0 Q అపాన్ డిస్టెన్స్, స్మాల్ ఆర్ అయితే స్మాల్ ఆర్, డిస్టెన్స్ అయితే ఆ డిస్టెన్స్, Q బై R స్క్వేర్. అవుట్ సైడ్ సేమ్ ఫార్ములా, కండక్టింగ్ నాన్ కండక్టింగ్ అవుట్ సైడ్ సేమ్ ఫార్ములా, ఆన్ సర్ఫేస్ ఆల్సో సేమ్ ఫార్ములా. ఆన్ సర్ఫేస్ ఆన్ సర్ఫేస్ అనేది సేమ్ ఫార్ములా అన్నమాట. ఆన్ సర్ఫేస్ దట్ ఫార్ములా ఈజ్ సేమ్. On surface 1/4πε0 Q upon capital R square. On surface conducting లో ఇన్సైడ్ ఇంటెన్సిటీ జీరో అవుతుందమ్మా. నాన్ కండక్టింగ్ లో ఇన్సైడ్ ఇంటెన్సిటీ జీరో కాదమ్మా, ఓన్లీ సెంటర్ దగ్గర మాత్రమే జీరో అవుతుంది. రిమైనింగ్ అన్ని దగ్గర డిస్టెన్స్ పెరుగుతుంటే ఇంటెన్సిటీ కూడా పెరుగుతుంది. దట్ ఫార్ములా ఈక్వల్స్ 1/4πε0 Q upon R cube. Just you observe Q upon R cube into small r. Q upon R cube into small r. Just you check this. This is non-conducting sphere. So non-conducting sphere, this is non-conducting sphere, the total volume. ఈ వాల్యూమ్ లో టోటల్ చార్జ్ Q అమ్మ. 1 యూనిట్ వాల్యూమ్ లో చార్జ్ Q అపాన్ 4/3 పైర్ క్యూబ్. అండ్ అగైన్ ఇక్కడ ఒక చిన్న వాల్యూమ్ ఈ పార్ట్ లో 4/3 పైర్ క్యూబ్. ఈ పార్ట్ లో మనం యూజ్ చేసినట్టయితే ఈ పార్ట్ లో వాల్యూమ్ Q అపాన్ 4/3 పైర్ క్యూబ్ ఇంటూ 4/3 పైర్ క్యూబ్. దట్ మీన్స్ ఈ పార్ట్ లో ఎంత చార్జ్ ఉంది, దట్ చార్జ్ ఈజ్ స్మాల్ క్యూ, దిస్ చార్జ్ ఈజ్ స్మాల్ క్యూ, దట్ వాల్యూ ఈక్వల్స్ 1 యూనిట్ లో చార్జ్ ఇంటూ వాల్యూమ్. సో ఈ పార్ట్ లో చార్జ్ ఇట్ ఈస్. After we simplified, TNVI is equals to total charge in this space. Again 1/4πε0 Q into R upon R cube. ఎలక్ట్రోస్టాటిక్స్ అనేది కొంచెం లాజిక్ రిలేటెడ్ అమ్మా, మీరు కొంచెం ధ్యానం పెడితేనే అర్థం అవుతుంది. లేదంటే ఈ టాపిక్ అనేది అడ్వాన్స్డ్ లెవెల్లో చాలా హైగా ఉంటుంది, ఆర్ మెయిన్స్ లెవెల్లో కొంచెం డిఫికల్టీ క్వశ్చన్స్ వస్తాయి. కాబట్టి ఈ కాన్సెప్ట్స్ అన్ని క్లారిటీ ఉండాలమ్మా. కాబట్టి ఈచ్ అండ్ ఎవ్రీ పాయింట్ నేను డిస్కస్ చేస్తున్నాను. ఈవెన్ మెకానికల్ స్ట్రెస్ అండ్ ఎనర్జీ డెన్సిటీ, చార్జ్ ఇచ్చిన వెంటనే సైజ్, బాడీ సైజ్ పెరుగుతుంది ఎందుకు అంటే మెకానికల్ స్ట్రెస్ ఆర్ ఎనర్జీ డెన్సిటీ. అగైన్ నాన్ కండక్టింగ్ స్పియర్ లో కండిషన్ ఏంటి, కండక్టింగ్ స్పియర్ లో మీకు కండిషన్ తెలుసు, ఇన్సైడ్ ఇంటెన్సిటీ జీరో. బట్ నాన్ కండక్టింగ్ స్పియర్ యూజ్ చేసేటప్పుడు ఇన్సైడ్ ఇంటెన్సిటీ జీరో కాదమ్మా. సో జీరో కాదు మరి ఎంత, that value equals to 1/4πε0 Q upon R cube into small r. సెంటర్ పొజిషన్ లో ఓన్లీ ఇంటెన్సిటీ జీరో అవుతుందమ్మా. ఓకే, సో ఓకే, థ్యాంక్ యూ. ఏమైనా డౌట్స్ ఉంటే అడగండి అమ్మా. హ్యావింగ్ ఎనీ డౌట్ చెప్పండి అమ్మా. ఏమైనా డౌట్ ఉన్నట్టయితే చెప్పండి. ఈజ్ ఇట్ క్లియర్? ఓకే.